Hey, hi YouTube. So in this video, we are going to see about large language models. So this topic is in buzz nowadays. Like you might have you might have heard about generative AI. And generative AI is completely based on this large language models kind of things. Okay. And in everyday life also, you might be using a lot of large language models. Like one of the famous is this GPT 3.5 Turbo, or you might have seen GPT-4 nowadays. Okay, so whenever you use ChatGPT, there are two options, which is one is freely available like GPT 3.5 Turbo, and second is GPT-4, which you have to pay $20 something. So this all are using large language models, and it makes very effective to our whatever projects you are doing, or whatever. Let's suppose you are trying to make some generative AI based applications. So in that case, large language models play a very crucial role, and definitely it's the time to change. So we should know about this, is happening in this world about large language models and all. So these are the topics that I think you should know in this LLM space. Means these are not the all topics, but okay, these are some like 2 to 3%. So like what is LLM, what is pre-trained model, fine-tuning model, what is fine-tuning, parameter, neural network, deep learning, transformer architecture, very important, data set, benchmark, prompt, supervised, self-supervised learning, zero shot, few shot learning, instruction based fine tuning, parameter efficient fine tuning, and transfer learning. So basically in this series we are going to cover all these topics. And today's topic, we in today's video we are going to cover these topics, this like a little bit about these three topics. Obviously all the topics are very large. Okay, like fine tuning is also a very different scope, a different subject, but basically we are trying to cover on the surface, like what you should know, like when you will hear the term pre-trained model, fine-tuning model. Okay, so first of all, let's see what is actually LLM is. So LLM is the full form of LLM is basically large language models. So you can like bisect into large language models. So large is like in context of large refers to the size and complexity of the model. Large language models are made up of vast number of parameters, the internal settings of the model learns, that make them very powerful in understanding and generating human language. These models are much bigger than earlier large language models. So basically, you can say that large is basically in terms of size and complexity of the model. Like you might have seen that when you ask a question to ChatGPT and you are using GPT 3.5 Turbo, which is the naive one, so maybe it would be not able to answer the question in a much more correct sense, or the way you want that answer. But if you use GPT-4, you might be getting the answer correctly. This is because the complexity of model, the size of model. Okay, it's like, let's suppose you are having a model. Okay, what is model? So model is basically computer science and machine learning. A model is a mathematical representation of framework that tries to mimic a certain aspect of real world. In the context of large language models, the models are complex algorithm or neural networks that learn patterns in language data. Okay, so its model is like a small brain. Okay, it's not small, a large brain that has a different capabilities. Like you might have seen that, let's suppose your age is 20. So how you have learned the things over the 20 years the 20 years of period, you have read lot of books, you have seen lot of facts and figures, you have slowly you have developed that reasoning capability, and that capabilities are inside this model. Okay, this- who have the scientists, the researchers have made this models like a human brain. Okay, not complete human brain, but they can have the reasoning capabilities. They, because of that mathematics, complex algorithms, and neural networks, that model can have that reasoning capability. Okay, reasoning capability, what reasoning capability actually they have? Like let's suppose you are trying to develop an application. Okay, and let's suppose maybe it is like a shopping app. Okay, and you are trying to ask a question like such, I am suffering from scurvy. Okay, suggest me a product and give its price and also the location. So what the reasoning that he can do, what the reasoning a model can do, first of all it will try to identify that which product can be suitable for a person who is suffering from scurvy. That will be vitamin C. So it will try to find on the vector DB that okay, which is the product in my corpus that is addressing the issue of vitamin C deficiency. Then it will basically try to find the price of it. Then the next reasoning will be that where it is. Maybe you are using a SQL database, or you are using vector DB, whatever it is. So it will break down the question. These reasoning capabilities are very important. Okay, initially it was with the humans only, but then the models developed, and because of this complex algorithm and neural networks, that they were able to make models. Okay, then language. What language is? Just a simple language, the natural language that humans speak, like English, Spanish, Chinese, and many others. So what these large language models are, if you combine all these things now, like there is a model, let's suppose there is a brain. It has been trained with large amount of data, and it can understand the basic language. Let's suppose it is able to understand English. Okay, so if you ask something to that model in our natural language, then it will be able to answer in our natural language only. So this is what in broad term LLM is. Okay, so you can just let me give you simple examples for the large world. Like imagine a massive library with countless books, each representing a piece of knowledge. A large language model is like having access to this entire library. Okay, enabling it to understand and generate a wide range of text. Lot of informations are there. Language is simple, like the think of a language model as a computer program that can read and write in multiple languages like Chinese, English, Spanish, a lot of that others are there. And model, as I said you, it is like a virtual brain made up of interconnected neurons. Large language models have billions of these virtual neurons, allowing them to process and understand text like in a sophisticated brain. It's not a human brain, but it's kind of a virtual brain. Okay, let's combine all this thing. So here you can see large language models refer to extremely complex and powerful computer programs that are built to understand and generate human language on massive scale. Okay, why they are able to generate human language? Because they have been trained on it. We will see what actually is training is. Okay, but they have been trained on it. Like okay, it's something like, let's suppose like how you teach a baby. Okay, like if it's not like you tell, let's suppose you tell a baby that 2 plus 2 is 4, then the human brain try to make some patterns like okay, 2 plus 2 is 4. So they develop some reasoning capabilities. It's not like if you if you teach a baby that okay, 2 plus 2 is 4, and then you gave him 4 plus 4, it's not like that he will not able to answer. Because of the 2 plus 2 is equals to 4, he was able to derive the pattern, and now he can also answer any kind of addition questions. Okay, I'm not talking about very complex questions, but the basic reasoning he has developed because of that neurons. Okay, so because of that we have trained on a massive scale, this large language models can answer a lot of different questions, and they can generate the answers. Okay, this is the very important part. Like the whole generative AI is based on the generating the part. Okay, it's not like many people think that how ChatGPT works, like they ask some question and it is searching on some database and then giving some response. This is wrong. Actually it is generating the response. Okay, it's not like if I ask some question to ChatGPT, might be he would not be trained on that data. Okay, it can generate something new because of its reasoning capability. Okay, because of this generating capability. That is the power of large language model. Like if you ask question like such tell me an essay or a song or a joke on maybe Joker. Okay, and then they will it will be able to generate some answer. Okay, you might never see that same answer again because that is a generative part. Okay, they are they are like vast virtual libraries with the ability to comprehend and produce text in multiple languages, and they do this through intricate mathematical models that stimulate aspects of human language understanding. These models are often used for various tasks, like you can see machine translation, chatbots. Chatbot is a very crucial, you can say, the application that a lot of companies are fighting for it. Content generation, this is also a very important part. You might have seen that, like if you want to make a YouTube video in year backs, like you might have to first design all the like what should be the introduction, what should be the description, everything you have to plan how to make a YouTube video. But now this content generation make the task very easy. Okay, you can just go to you go to ChatGPT and say that I have to make a YouTube video, give me the script and all things. So this content generation part is also very very important. Due to the generative nature of LLM, you can use it in your application or whatever enterprise application, whatever personal application you are developing, and much more. Due to the ability to handle and generate human-like text across different languages and topics. Because why is this very famous? Because of it is able to generate answers in our language. It can be in any language like Hindi, English, Spanish, Chinese, whatever language you are following. Okay, now here you can see the how the trend of the numbers of LLM model is introduced over the years. So you here you can see there is a high growth. Okay, so that's why I'm telling you that this is very very important. Okay, so you should be like this is not just a flow. Okay, it's not like just a wave. Okay, you like it's a trend. Okay, it's not like that for some time this will be in the hype, then suddenly it will disappear. It's not like that. Okay, it will be in the market for a long time. So that's why you should learn about the large language model. Okay, and this is basically, I think I have taken from a research paper. Like it might be the data might differ. Like I think this data will already will be high now. Okay, so here you can see like in 2009 there was only one like only one open source model was there. Then suddenly it's grown to 315, then 27, then 29. So there are a lot of open and closed model. Like open models are like the models which are open source, whose code is easily visible to everyone. But the closed source are like you can use it through APIs or by their platforms, but you can't use it. Like GPT 3.5 Turbo, you can't find the code, you can't find their secret recipe. Okay, even for GPT 4, so they are closed model. Okay, but a lot of models are there which are open models. Okay, whose code are easily visible, so you can use it. Okay, now, what there are some different terms also which you should know. Like this is a pre-trained model. What is pre-trained model? So pre-trained model is a type of machine learning model that has been trained on a large data set for a specific task before it's fine-tuned for a complex task. Okay, so let's suppose you are having a model and you have trained it over different across with different training data. So that is a pre-trained model like GPT 3.5, which you are using in Chat GPT. That is a pre-trained model. Okay, so what actually pre-trained model is, like it is not designed for a specific task. Okay, it is just designed for all over the task. Okay, let me give you some examples of pre-trained model. Like this is BERT. Okay, BERT, the full form of BERT is bidirectional encoder representations for from transformer. Okay, so like BERT is a pre-trained model developed by Google only that understand the context in the language. Okay, it can be fine-tuned for various NLP tasks such as text classification, sentiment analysis, like entity recognition. Okay, for example, it can be also built a sentiment analysis system for analyzing customer reviews. So this is also a pre-trained model. Then GPT, basically you can say GPT is a generative pre-trained transformer model. So GPT is another a pre-trained model that can generate human-like text like GPT 3.5, GPT 4, all this generative pre-trained transformer. Okay, it can be used for translation, text summarization, chatbot development, Okay, so you can also fine tune it. It's fine tune. It's like if you are confusing with it, fine tune. It's fine tune is whenever you are making a generalized thing. It's a pre-trained model. Like let me give you an example. Okay, if you go to ChatGPT and if you ask like any question about your family members or let's suppose for your company. Okay, let's suppose you ask like who is the maybe admin of XYZ. Okay, let's suppose XYZ your company. So obviously our GPT will not able to answer. Okay, because it is a pre-trained model. Okay, because it is not having the information about your XYZ company admin. Okay, now if you ask who is the Prime Minister of India, it will be able to answer it because when it was being trained, it was having that information. That's why you might have seen, like if you ask some recent questions about LLM, LangChain, then it will tell that okay, my knowledge was cut off like in 2021, so I am not able to answer questions that has been developed after 2021. But coming back to this example, but if you have, let's suppose 10 pages of a doc of your company, okay, like who is admin, who is CEO, who is CTO, who is CFO, every information, okay, what employees are there, their information, which brands they are working, in which project they are working, and if you trained this GPT, this same GPT 3.5 or GPT-4, and you trained all this data to GPT, then it will be able to answer it because we have fine-tuned it. We have fine-tuned it for our own data. Okay, so now it will be able to, we have trained it on our own data. Okay, it might be not the complete definition of fine-tune, but I am just giving you a analogy. Okay, then there is ResNet. It is also a pre-trained model. So ResNet is basically residual networks. Okay, like the full form is residual network. It is a pre-trained model for image recognition. Okay, you can use it as a starting point for a task like object detection, image classification, facial recognition. This is very famous. Like you might have seen that age recognition. Yeah, there are some applications now like you upload a photo, then they will tell whether it is male or female and its age that kind of thing. Okay, so you can do this by this ResNet model. You can simply use this model and develop some good applications out of it. Okay, for instance, ResNet can be fine-tuned for a custom object detection for autonomous vehicles. There can be a lot of applications. Then YOLO, you look only once. It is a pre-trained model for real-time object detection. It is commonly used in applications like security cameras, where it can detect and track objects in live video feeds. Okay. Then there is a deep speech, which is a very famous one. Like deep speech is a pre-trained model for speech recognition that is developed by Mozilla. Okay, it can be used to convert spoken language into written text, okay, making it useful for applications like transcription services or voice assistant. Okay, this is also important thing. So see, all the pre-trained models are having different goals. Okay, like ResNet is for image. Okay, deep speech is for speech. GPT is for basically the GPT is more famous for its text summarization, chatbot development. Okay, like BERT is mostly famous for various NLP tasks like sentiment analysis, classification. So you can use any of this model and you can develop some good application, and obviously you can learn a lot of things. Okay, so this is what pre-trained model is. Okay, so, but how actually we can use this pre-trained model in our application? Okay, let's suppose we are trying to develop an application and how we can use this pre-trained model. So first is the loading the pre-trained model. So you start by loading the pre-trained model. Many pre-trained models are available as open source. Like let's suppose Flan T5 models are there like XXL small. So first of all, you have to download this model. Okay. And if the size is very large, you can also access this through the APIs. Okay. Or let's suppose you are having a model, you can deploy it to like what we can say to an instance. Okay. AWS instance or GCP instance, and then you can make a API endpoints and you can directly use it. Sometimes if the size of model is very large, obviously our own system will not able to handle it. Okay, so first of all, you have to load that model, you can easily import into your code using frameworks like TensorFlow, PyTorch. Okay, you can easily get it. If it is open source, you can easily get it. Okay, then you can fine tune it. Let's suppose you are having some idea, or depending upon your specific application, you may need to fine tune the pre-trained model on your own data set. Okay, this involves training the model on your data to adapt it to your own task. Okay, fine tuning typically requires less data and time than training from scratch. It's not like, see, if you want to develop an application, okay, it's not like you have to make the model on your own. Simply you can use GPT 3.5 turbo, you can use bird, you can use any model. Okay, let's suppose, okay, I'm just giving an example. Okay, coming back to that office example. Okay, let's suppose you are trying to develop a GPT for your office person. So it's not like you will create a own model. Okay, it will take huge amount of time, huge amount of money, it will take a lot of expertise. But what you can do is you can just use a pre-trained model like GPT 3.5 turbo. You use it, then fine tune on your own data set. What is your data set? The data of your office. It might be in a PDF, it might be in a CSV, whatever format it is. Give this data to the GPT 3.5 turbo, you fine tune it. Okay, obviously fine tune is not a piece of cake. Like, it takes a lot of expertise and a lot of time. Okay, depending upon the use case, then you can fine tune the model. Then inference. Once the model is fine tuned, you can use it for inference. Inference means using the model to make predictions or to generate outputs based on the new data. For example, you can use a fine-tuned text classification model to classify new text documents. Okay, so here you can use this after the fine tune, you can use to generate your own data. Okay, then you can deploy it. Obviously, if you want to make available for other people's, okay, then you have to deploy it. You can deploy your application with a pre-trained model and fine-tuned model to make it accessible to users. This can be on a website, a mobile app, or any platform suitable for your application. Okay, you might be thinking like, is this fine tune always important? No, it's not like that. Let's suppose you are trying to develop an application. It's it sounds very dummy. Let's suppose you are just trying to develop an application like, whenever a person will enter some text in English, that it will summarize it and return it into Spanish. Okay, so this can be easily done. You can just use the pre-trained model like GPT 3.5. Just whatever input you are having in English, just pass it to GPT 3.5 turbo. It will summarize it and it will translate it. Because this is a very general task, because already machine knows about English, Spanish translation, so it can easily do it. Summarization, it can easily do it. But if there is a specific task, like here we were asking about our office data, which is not maybe the GPT 3.5 turbo is not trained on our office data. So in that case, it will not able to answer about the questions or query related to our office members. So that's why we have to fine tune it. If it is not needed, you can also skip these steps. Okay, then let's see about fine tuning. Okay, so fine tuning is a machine learning technique used to adapt a pre-trained model to perform a specific task or solve particular problems. Okay, already I've talked a lot about fine tuning. Okay, so basically it's a machine learning technique used to adapt pre-trained model to perform a specific task. Like I told you now, like if there are some specific tasks which is not general task, then we have to use fine tuning. Okay, so like let's see like how fine tuning works. Okay, so fine tuning is like pre-training. First of all, initially a model is pre-trained on a massive data set with a lot of text. Okay, during this phase the model learns the general patterns, grammar, language understanding from the vast amount of data. For instance, a pre-trained model can learn to understand context, syntax, and semantics, which is already there. But in fine tuning, after the pre training, the model is fine tuned for a smaller data set that is specific to a particular task. The data set includes labeled examples for the task you want the model to perform. During fine tuning, the model adapts its pre trained knowledge to better fit the specific task. Okay, so already I have talked a lot about pre-training and fine-tuning. Like it is for a specific task, this is for general task. Okay, whatever models are available, closed source or open source, they are mostly pre-trained model. Okay, if you ask for summarization, translation, they can easily do it, but they can't answer about your personal information, or about your specific use case. Let's suppose you are trying to develop a chatbot, okay, on your different use case, so it will be not able to answer it. So this can be answered using fine tuning. Okay, so what are the examples of fine tuning, like where we can use the fine tuning? Okay, so first one is text classification. Like, suppose you have a pre-trained large language model and you want to classify news articles as either it is positive or negative sentiment. Okay, you might have seen that a lot of news are there, but if you want to classify like positive or negative, you have to do it manually, but we can also take the help of LLM and we can do it. So the sentiment analysis, the text classification, you would fine tune the model on a dataset labeled news article with their corresponding sentiment labels. Okay, like, okay, let's suppose you are using GPT 3.5 turbo. Okay, and obviously it will be not able to predict whether this news is positive or negative. Okay, because it might be not trained. But what you can do, you can have a data set of, let's suppose, 500 different news articles, and you classify it. This one is positive and this one is negative, and you created a data set. Okay, and you then fine tuned it, the GPT 3.5 turbo. Now the GPT 3.5 turbo will able to understand or to classify the sentiments of that news, that whether it is positive or negative. Then it can answer to different millions of news. It can do, it will develop that reasoning capability, and then it can, out of it, it is not like that if you ask questions among this 50 100 only, then it can um, provide the sentiments whether it is positive or negative. It can answer millions of different other news articles whether they are positive, whether they are having positive or negative sentiments. Okay, because it will develop the reasoning capability through that data set. Okay, now second one is name entity recognition, like which we call NER. You want to identify entities like names of people, organizations, and location in text. Fine-tuning a language model on a labeled NER dataset allows the model to recognize these entities very accurately. Okay, like you want to like predict, like you want to identify whether this is a name of people, or this is a name of organization, or this is a name of location. Okay, like let's suppose you are trying to develop an application. Okay, and you want that in application only human will answer and no one will promote their organization. Okay, so if you want to ban this thing, okay, so organization name can be different thing. You can't do it manually, okay, because million of users are using that application. Here you can take the help of this LLM, the fine-tuned model, and you can identify whether this is an organization name or not, and you can ban it. Okay, I'm just giving an example. Obviously the accuracy is not like 100%. Okay, because obviously the better training data set you will give, the better results you will get. You might have seen, like, you are there in college, and there was the same your friend was also there in college. Okay, but maybe you would be scoring some high marks, and your friend was not able to score that high marks. Okay, both are reading the same books, or maybe they are trained by the same teacher, but still they are getting different results. Why? Because the amount of data set they have been trained, the quality of data set. You might be reading some quality books, you might be uh, giving some more time while studying that books, or analyzing it. Okay, so, and it is possible, it might be possible that your friend is not studying that quality books. Okay, he might be just going through the surface. So that's why the better the training data we will be having, the much better accuracy we will get. Okay, then machine translation. So for translation task, you can fine tune a pre-trained model on a parallel corpus. Okay, to make a proficient at translating between those specific languages. This is a very basic thing. Okay, but you can also fine tune for better machine translation. there can be some languages on which the GPT 3.5 Turbo is not pre-trained on. So you can train it. Okay, you can fine tune it. Okay, then question answering. This is a very basic one. Okay, fine tuning can be used to train a model to answer questions based on a given context. The model is fine tuned on a data set of questions, answers, and the context of that passage. Okay, so these are some examples of fine tuning. Okay, what are the applications of fine tuning? The first one is very famous, custom chatbots. Like you can fine tune a language model to create a chatbot that specializes in customer support for your business. Okay, it will understand and correspond to customer inquiries effectively. Okay, then content recommendation. Okay, like fine tune models can be used to recommend articles, videos, or products to users based on their preferences and interactions. Then medical diagnosis. In healthcare, fine-tuned models can assist in diagnosing medical conditions based on the patient records, symptoms, test results. Okay, like if you are having records of patient symptoms and test results, it can basically give the diagnosis like which medical things you are having, what are the symptoms, how you can cure it, all things. Okay, but definitely doctor is needed. Okay, then sentiment analysis. So sentiment analysis, like you might have seen, like fine-tuned models can be employed to analyze social media posts or customer reviews to understand public sentiment about the product, service, or event. Like you might have seen, there were some ideas like I was going through it. Like if you have a picture, okay, in social media there are a lot of pictures. So how we can classify whether it is a good picture or bad picture? So this can be also done by this fine-tuning. Okay, then legal document review. Legal professions can use fine-tune model to review and extract relevant information from legal documents, contracts, and case laws. Like maybe your contract or your legal documents are of like 80 pages, okay, and you want to just get a review of it, or you want to extract just a part, you want to ask some questions and you want to get the answer. But for that, you have to read that 800 pages legal document. So that can be easily done by the fine tuning. You just provide that document and you can ask the questions. Okay. Image captioning. Although fine tuning is often associated with language models, it can also be applied to image captioning models by training them to generate descriptive captions for a specific image domains. Okay, obviously, most of the things we can also do with the pre-trained model, but the accuracy will be not there. Okay, when you will develop that application on your own for your personal project, for your company, for your enterprise level, you will understand that what are the challenges you will face. Okay, so fine tuning is a very important part. Okay, you can't rely every time on the pre-trained model. Okay, so now let me give you a basic analogy to understand what actually pre-training and fine tuning is. Okay, let's take a simple example of riding a bicycle. Okay, so think this is pre-training. Okay, think like pre-training as the learning of basics. Okay, before you even get into the bicycle, like you start by watching others. Okay, initially it's not like directly we start riding the bicycle. Okay, you start by watching other ridings. Okay, like understanding how the pedal or handlebar works. Okay, and getting a general feel for it. This is like a computer model being pre-trained on a lot of text data to understand languages in a general way. It learns grammar, it learns vocabulary, and the context. Okay, like the baby was seeing someone like who was riding the bicycle and was trying to grasp or to was trying to take a feel like how the bicycle is riding. The same way, pre-trained model also we learn everything. Okay, it's like riding a bicycle on a straight road. Okay, but what happens in fine tuning, like you might have seen some riders are trained to ride on sleepy areas. Okay, some are trained on bicycling on that mountain regions. They are for specific tasks. Okay, it doesn't mean that they can't ride a bicycle on a slope, okay, or on a plain road. But if a person is riding a bicycle on a plain road, it's not guaranteed that it can ride for a long time in that mountain regions. Okay, are you getting my point? So whatever task the fine tuning model can do, it can be also done by, sorry, whatever task the pre-trained model is able to do, it can be also done with the fine tuned model. But the fine tuned model will be having much more reasoning capability than a pre-trained model for a specific task. Okay, So in fine tuning model, we can say now let's take now you can say that you want to ride a bicycle in a specific place like a hilly trail or a crowded city. Okay, fine tuning is like taking your general knowledge of riding that you have learned in the pre-training, okay, and adapting it to a specific conditions. You practice on that particular trail or street to get better at handling those challenges. Similarly, in machine learning, fine tuning takes the pre-trained model and adjust it for a specific task or a data set. It's like customizing your bicycle rating for a specific environment. Okay, that was already I was this was just an analogy to give you some basic example like how you can basically you can correlate it with. Okay, so this is the pre-trained model. Okay, and this is the fine tuning model. Okay, fine tuning model is just for a specific task. Okay, so okay, that's it for this video. From the next video, we will cover some more topics like parameters and all. Okay, so I think you might have learned a lot of things today, like what is LLM and what are like pre-trained models and where we can use it, how we can use it, what is fine tuning, how fine tuning works, what are the examples where fine tuning can be used and applications of fine tuning. And I have also given a basic analogy to so that you can understand what is the difference between pre-trained model and fine-tuning model. Okay, so there are a lot of keywords remaining like parameters and all. We will discuss it in further videos. Okay, there can be a series of videos because in one video we can't cover each and everything. Okay, and this all topics are also very huge topic. If you want to learn about fine-tuning, if you want to learn about pre-trained model, you can tell in the comment section. I will definitely make a video or I can provide some white papers that you can go through it and you can understand like it's a ocean. Okay, every day a lot of things are coming into the market. It's hard to grasp each and everything, but these basic things, these things, if you know these things, these all topics and many more are also there, but these basic topics if you know it now, then you can understand any kind of white paper and you will be having the basics of the LLM, generative AI and all stuff. Okay, so that's it for this video. If you like it, please like, comment, share and subscribe. And if you have any doubt, please ask in the comment section or whatever suggestions you are having, or if you have any information you can share it with me so that I can include in the next video because everyone is growing at their own pace. Okay, so that's it for this video. Meet you in the next video. Till then, bye bye. Thank you.